king cobras, inland taipans, Du Bois sea snakes, black mambas. They're all heavyweight members of a single snake family that first evolved around 38 million years ago. And it's no exaggeration to say they've been at war with the rest of the animal kingdom for a very, very long time. In that war, this snake family brought along a secret weapon that suddenly made the prehistoric world far more dangerous. A venom that targets one fatal weakness, an Achilles heel buried deep inside the nervous systems of almost every ancient vertebrate, forcing them into an evolutionary arms race. A war that not even the ancestors of humans could escape. Snakes are an ancient group. The very first snakes began slithering across the land near the end of the Cretaceous period, almost 100 million years ago. The family Elapidae, however, is much younger, not even 40 million years old. Hey, how old are you if you think 40 million years is still young? Despite being evolutionary youngsters, elapids are astonishingly diverse. Out of roughly 600 venomous snake species on Earth, more than half, around 360 species, belong to this single family. The rest are spread across the families Viperidae, Atractospididae, and Colubridae. In fact, once scientists reorganized the snake family tree, they realized that Elapidae had diversified at a speed never seen before, the fastest radiation of any reptile group. Some of the biggest names in the snake world, from the king cobra, the world's longest venomous snake, to the black mamba, one of the deadliest snakes on Earth, to the most venomous sea snake, Du Bois sea snake, and the undisputed champion of venom, the inland taipan. They're all on Team Elapidae. And much of Elapidae's success comes down to one exquisitely refined weapon. First of all, elapids didn't invent venom. Venomous snakes existed long before the very first elapids appeared. That's the name for snakes in the family Elapidae. In fact, snake venom may even be an ancient inheritance passed down from scaly ancestors that evolved it from a toxic form of saliva. Pretty wild. But it wasn't until the elapids took over that snake venom became an art form. Many rear-fanged snakes can inject only small amounts of venom at relatively low pressure. Elapids, on the other hand, play in an entirely different league. They evolved hollow front fangs that work like hypodermic needles, allowing them to literally inject high-pressure venom straight into their prey. While the venom of many front-fanged snakes, such as vipers, mainly attacks the victim's cells and tissues, destroying them piece by piece, elapid venom is far more devious. Its main weapons are neurotoxins that rapidly paralyze and kill by sabotaging communication between the nervous system and the rest of the body. More specifically, these neurotoxins bind to nerve receptors inherited from an ancient lineage of vertebrates. Think of them as fatal weak spots, mobile Achilles heels. Once those neurotoxins lock onto these receptors, they block electrical signals from leaving the brain, shutting down essential functions like movement and breathing, leading to a slow but inevitable death within hours, or sometimes just minutes. The moment the neurotoxin update went live on Earth's server, almost every vertebrate species had only two choices: join the evolutionary arms race, or disappear. Game over. And funnily enough, the fiercest competitors in that race weren't humans, or any animal you're probably thinking of. They were a bizarre group of legless amphibians that look like worms, or snakes, called caecilian. And yes, that's Sicilian, not Sicilians. Everyone. Sicilian have backbones. And they're definitely not worms. In fact, those half-worm, half-snake creatures you're looking at are incredibly ancient. They appeared more than 100 million years before the very first snakes. So technically, it's more accurate to say that snakes look like Sicilian, not the other way around. Yet despite belonging to the lifelong no-legs club, Sicilian and elapids have never exactly been best friends. Quite the opposite. For a long stretch of evolutionary history, they were bitter enemies. When researchers analyzed the nerve receptors of different caecilian lineages, they made a stunning discovery. Around the same time that elapid snakes began rapidly diversifying and spreading across the world, Sicilian independently evolved resistance to elapid neurotoxins at least 15 separate times. Wow. And if this is your first time hearing the term, convergent evolution is when distantly related organisms, living in different places or even different eras, independently evolve similar traits in response to the same evolutionary pressure. For example, both birds and bats evolved wings, while cacti and many flowering plants independently evolved spines. Now, back to the caecilian. Their resistance to snake venom evolved independently all across the planet, from the Americas to Africa and Asia. The outcome was the same, but the solutions were completely different. Each caecilian lineage evolved its own way of fighting snake venom. Some developed mutations that prevent the toxins from binding to their nerve receptors. Others altered the shape of those receptors so the toxins no longer fit, like changing the lock on a door. Some got even more creative, changing the electrical charge of the receptors so they literally repel the toxins. And a single caecilian species may use more than one of these strategies. Pretty clever. The sheer scale of this evolutionary arms race against snake venom is virtually unprecedented. And although caecilian can't exactly tell us their side of the story, scientists have a pretty good idea what happened. Because caecilians spend their lives underground, and elapid snakes specialize in hunting burrowing animals, they likely endured an immense evolutionary pressure, being hunted and eaten countless times across the globe. A dark age you could almost describe as the apocalypse of the caecilian. Yet from that worldwide slaughter, the lucky few carrying valuable mutations survived, rebuilt their populations, and rescued their entire lineages from extinction. The war between caecilian and the family Elapidae is still being fought in almost every corner of the world, with one remarkable exception: Seychelles. This island nation broke away from the Indian plate around 66 million years ago, at roughly the same time the dinosaurs were disappearing, and tens of millions of years before the first elapids ever slithered onto the scene. The caecilian of the Seychelles were lucky enough to miss the Great Massacre entirely, but they're also the only caecilian on Earth that never evolved receptors resistant to snake venom. They completely sat out the evolutionary arms race, which makes perfect sense, because there were no elapid snakes there. So you chose death. And the war between caecilian and elapids is just one battle in a much larger global conflict against venomous snakes, involving many different groups of vertebrates. And although no other group evolved resistance as spectacularly as the caecilian, similar mutations have also been found in zebras, mongooses, and of course, the honey badger. And since our ancestors definitely had legs, humans couldn't stay out of the war against snake venom either. Scientists exposed nerve receptors from many different primates to snake neurotoxins and discovered that the common ancestor of chimpanzees, gorillas, and humans evolved some of the strongest resistance of them all. That resistance was passed down to their descendants, including us, making humans among the most venom-resistant primates alive today. Whoa, whoa, don't take that as permission to go play with venomous snakes. Absolutely not. You are not immune to snake venom. Not even the honey badger is. All this really means is that among primates, humans are simply one of the species that can tolerate snake venom better, because our ancestors encountered venomous snakes more often than almost anyone else. Take cobras, for example. They lived alongside our tree-climbing ancestors, were active during the day just like they were, and had absolutely no problem standing their ground against much larger animals when threatened. Once our ancestors came down from the trees, encounters with cobras became a regular part of life. Those without any resistance were less likely to survive. Those with even a slight advantage lived on, returned home, and passed that resistance on to the next generation. Round of applause. On the other hand, primates that rarely, if ever, encountered venomous snakes, such as the lemurs of Madagascar, have almost no resistance at all. They're basically the Seychelles caecilian of the primate world. As the old saying goes, one good turn deserves another. I still have no idea what the original Vietnamese pastry in that proverb actually is, but in return for helping toughen up our descendants against venom, our ancestors may have accidentally given cobras a gift of their own. Some researchers have proposed that, after millions of years of being pelted with rocks and jabbed with sticks by early hominins from a safe distance, cobras evolved a long-range weapon of their own. Venom spitting. Music. Yep, you heard that right. Our ancestors may have taught cobras that trick. Well, that's the scientists' hypothesis. What do you think? Let us know in the comments below. And if snakes give you the creeps, don't forget to leave a like. As always, Subscribe to the channel and ring the bell so you won't miss any of our animal stories. Until next time, thanks for watching and see you again.